So I'm Thomas Langvann. I'm the product leader of the Norwegian Web Archive. And Jon has already introduced himself. So we will together present a work to classify the records in our collection with an objective to open as much of our archive as possible for as many as possible. So first we'll start with presenting the current situation and the Norwegian case. And second, we will present an effort to produce acceptance criteria for automatic classification. And third, we will evaluate our experience with those different approaches. This one, okay. So, but first, the problem. So providing wide access remains a challenge for many web archives. And the hurdles are not always technical. Several are actually legal or ethical issues. And in Norway, legislative preparations have suggested a multi-layered model for access. This is mainly based on the content's copyright status and the degree of personal sensitive data. However, this information about these matters is rarely declared in the content we harvest, at least not in a uniform or standardized way. So, this is the suggested model for multi-layered access in Norway. So the first category, category 1, easy. It's websites and domains that are owned by public institutions. So access is open for all individuals without any restrictions in a public service.
Yeah, category 2, that's publications that has declared a responsible editorship, and we can give access to anyone on premise in our own localities or at the university libraries. So that is content declared that someone is taking the ethical and legal responsibility for the content. That is also quite wide access. For category 3, this is, it's a miscellaneous category. Not a really good category, but it's in principle everything else. So except public domains and responsible editorship, that falls into category 3. Accessible for researchers after a publication, after an application, with some kind of relevant research purpose. So for researchers, they can, in principle, get access to everything. And for the last category 4, that's restricted material. In practice, I think it's less than 10 resources. A couple of examples from hospitals publishing data they weren't supposed to publish. But in practice, we really don't have anything in category 4. So we started out with a hypothesis that we needed one or several of these approaches to kind of identify the access category. So 2 of them are typical rule-based approaches, linking data and programming, mostly with regular expressions. And the third approach, machine learning, training models that could identify content. So that was our hypothesis, or like toolbox, when we started.
So for the first category, public domains, our approach is linking data to the Norwegian entity register. So we do not have access to the full register of Norwegian domains. So the process is to get entities from the entity register and to filter out public entities. And then we query the Norwegian register for domains registered on a particular organization. So the list returned from the register is used as a whitelist for declaring domains as category 1 with access for all. So here you can see in a given when-then model how the acceptance criteria.
Yeah.
So on the left side and some pseudocode on the right side here. So to handle this computationally, we can define these acceptance criteria.
So for the responsible editorship, how do we identify this? And it's quite easy if you look at the content. You just need to, you can't look at the work, you need to go deeper into the content. So from this, what appears as a footer, you have a responsible editor and his or her name. You also has a reference to what in Norway is the declaration of your duties as a responsible editor. So like a code of conduct, editorial code, and also actually in semiotics in the bottom. So this is the icon of the editorial code. Yeah. So again, like defining the acceptance criteria on the given when then format. So given the front page of a domain, when it declares responsible editorship and link to the editorial code, we regard that as classified as category 2. So some more pseudocode. So we've we made a test data set with front pages from 300 news sites. And currently, this is just the first iteration of the code, so we can improve it vastly, really. But just the first iteration, we found 83% correct classifications. 14% are declared as uncertain, meaning there's some indications, but the algorithm isn't sure. And the reason often is that the declaration is not necessarily in the front page HTML code. It's declared in dynamic content or on other HTML pages. We also have 3% false negatives, which we can improve also with the same looking at dynamic content and other pages than the front page. But I think the most important is that we have 0% false positives. So we're not risking at the moment, we feel, to declare something as access category 2 if it shouldn't be that.
Yes, and as Jon mentioned, category 3 is basically the rest of the domains not identified as category 1, 2, or 4. And they are restricted to researchers because of the risk of personal data, not widely known. So our hypothesis was that natural language processing, NLP, might be a good approach for detecting personal data. But actually, as Jon said, we don't need it for giving access because this is researcher-based access. So we can identify access categories with this rule-based approach. So there's no need to fire up the power plant with machine learning when you can just use regular expressions and linking data. But still, there's a desire amongst researchers for derivatives. Machine learners need data as well to train models. So we believe that machine learning might be a really good approach to both detect and maybe suppress sanitized data. But that's outside the scope of what we've been doing so far in this project. So we are looking to partner with AI labs and environments to help us out with this. And for this task, machine learning will be crucial. So to conclude, the legal framework rely mainly on semantic information. And even if it's not structurally declared, it can be identified through computational analysis of content with a high level of certainty. So in this case, classification can be handled with relatively simple rule-based approaches. So while we see the value of machine learning in general, for the classification problem, it's overkill. And as Jon mentioned, we've done some iterations with this, the regular expressions and the testing. So the bottom link here is a link to the Jupyter notebook, which we used for evaluating these approaches. Thank you.
Thank you.